Today's lesson is 5.8, Measures of Central Tendency. So today what we're going to talk about is analyzing data and seeing how we can best describe a large set of data using three measures of central tendency. You may have heard them already, you may have discussed these in previous classes, but we're going to talk about mean, median, and mode. So let's go ahead and jump right in. When you have a list of numerical data, it is often helpful to use one or more numbers to represent the whole set. These numbers are called measures of central tendency. These are the three types we're going to study. The first one is mean. A lot of times you might have heard this as the average. Okay, well, mean is the sum of the data divided by the total number of items in the data set. Okay, so that would probably be your average that you might have talked about earlier in a previous course. The median is the middle number of the ordered data set. So if they were in order, the median is the one in the middle. Now, if there are two in the middle because there's an even number of data sets or even number of items in the data set, then you would just take the mean of the two in the middle, or the average of the two in the middle. And the mode is the number or numbers in the set that occur most often. Okay, so let's try an example of these. So here's our example. Alright, now that you've paused already and written it down, the heights of the players of the boys basketball team are shown in the chart. Find the mean, median, and mode. Okay, so there's the chart. The height in centimeters of these 12 players on the basketball team are here. So find the mean, median, and mode. Well, how do we find the mean? Well, the mean is equal to the sum of the data divided, or the sum of the data, divided by the total number of items. So the sum, and in this case the data is measuring height, so the sum of the heights divided by the number of players. Okay, well, that is equal to the sum of the heights, so 130 plus 154 plus 148 plus 155, and so on and so on and so on and so on. You add all those up. I'm assuming you did that already. Well done. And you probably got the same thing I did, 1,824. And you divide that by the total number of players. Well, there are 12 players, and it works out to be the average height of the players is 152 centimeters. Okay, so the mean height is 152 centimeters. Now, how do you find the median? Well, let me erase this here because we already have the mean. You've got that written down. Good. Okay, so how do you find the median? Well, the median, it says, is the middle number of the ordered data set. So to find the median, we have to order the numbers from least to greatest. So the smallest is 130. The next one, 140. Then, okay, I'll give you a minute to do this. I'll just go ahead and zip it up. Alright, I cheated a little bit. It was easier for me to type it out, and it was much neater, trust me. Okay, so once we've ordered them, we've laid them out in order from least to greatest. The median is the middle number of the ordered data set. Well, there are 12 of them, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there is the middle, but there's an even number. So what we have to do is we have to take the mean of 152 and 153. So to do that, or the average of 151, 153, so we add 151 plus 153, that's a 3. Then we divide by 2, and we get 152. This one's a little bit easy. You can say what's exactly in between 151 and 153. The answer is 152 centimeters. So the median, the middle number of this set, is 152 centimeters. The last part is what is the mode. The mode is the number or numbers in the set that occur most often. And what is the mode in this case? Well, in this particular case, there is no mode because each number in the set occurs only one time. Okay, so we would say no mode for this example. Alright, let's see if there's an example where there were multiple data entries that were the same. Alright, so this question says a line plot, So this question says, the line plot shows the number of Atlantic hurricanes that occurred each year from 1974 to the year 2000. Find the mean, median, and mode. Okay, so here's how we would read this. Each dot represents a year, 1974, 1975, 76, 77, and so on. And every year, this year particularly, there were 2 hurricanes. This year there were 11. This year there were 5. This year there were 7. This year there were 3. This year there were 3, and so on. Alright, so each dot represents a year, and that year's dot got placed based on however many hurricanes they had that year. So if we had to find the mean, how do we find the mean again? Well, if we want to find the mean number of hurricanes, we need to figure out how many hurricanes there were. Okay, now we could count these up, 1, 2, 3, 4, 5, and you get 27 dots. But remember, the dots represent years, not number of hurricanes. So, how many hurricanes were there? Well, this year there were 2. Plus, some years there were 3. How many years were there 3 of them? 1, 2, 3, 4. So I have to count 3 4 times, because there were 4 years where there were 3 hurricanes. Plus, how many years were there 4 hurricanes? Well, there were 1, 2, 3, 4, 5 years of 4 hurricanes. How many with 5 hurricanes? There were 5 years. There were 2 years with 6 hurricanes, and 3 years with 7. Oh, running out of room. Let me watch this. I'll slide the whole world. There, move the question. Woo. And 8. There were 3 years with 8, plus 2 years with, 9. 2 years had 9. Let me clean that up. 9 hurricanes happened for 2 years. Then 10 hurricanes happened only once, so I could do that if I wanted to, but I don't need to, just like I could just write 11 there. Okay, so now let's see if I can move this over here back to the original spot, and maybe I will zoom. Ooh, can't zoom very well. Let's see. Okay, we kind of get the idea. There we go. Okay, so to find the mean, I add up all the number of hurricanes. And this, if I can get it to show here, this shows how many hurricanes there were. What I need to do, though, is I need to divide now by the total number of data sets. Well, in those data sets, these dots are the number of years these hurricanes were measured, and that was 27. So I do this calculation, calculator atop your shoulders, add all these up. 2 plus 3 times 4 is 12, plus 4 times 5 is 20, plus 5 times 5 is 25, 12, 21, and so on. Divide by 27, and I get approximately, we'll use this, equals with a dot over it, approximately 5.7 hurricanes, which means there's about 5.7 hurricanes per year. Okay? Now, the median would be the number or the average of the two numbers, which is in the middle. So if there are 27 numbers, 27 data sets, 2, 3, 3, 3, 3, 4, 4, 4, 4, and so on. Okay, so there are 27 numbers. The middle one, there is a middle one, would be the 14th, because there's 13 on one side, 13 on the other, so 14 is the one in the middle. So I just count them from smallest to largest: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and this right here is my middle number, so that means the median is 5. And the mode is the number that shows up, or numbers that show up the most, and you can see that 4 and 5 are the years that, or are the hurricanes that counted the most, showed up the most number of years. There were 5 years where there were 4 hurricanes, 5 years where there were 5 hurricanes. So the mode is 4 and 5, so there are 2 modes, 4 and 5. Alright, not so bad. Let's try another example. Next idea is A number in a set of data that is much greater or much less than the rest of the data is called an extreme value, or an outlier, and can affect the mean of the data. Alright, so if you've got a lot of data that's pretty close together and you've got one or two guys way out on either end, it's going to pull the mean in that direction, whether it's high or low, based on what and how many outliers there are. Let's see how this shows up in an example. So this example states, the table shows the number of calories per serving of each vegetable. Okay, so a serving of asparagus, a serving of beans, a serving of lettuce, a serving of celery, a serving of corn, and how many calories is in each. So a serving of asparagus is 14 calories, a serving of lettuce is 9 calories, a serving of cabbage is 17 calories. Identify an extreme value and describe how it affects the mean. Okay, well, if I look at these data sets, okay, I can sort of see a pattern. They're not really close together necessarily. They're not really clumped together. Okay, I've got some 9s, I've got a 30, a 20, a 25, and then I've got this guy right here sticking way out. Okay, sure, there's a decent jump between 9 and 20, but there's a huge jump between 9 and 66, or even 30 and 66, from the highest to the second highest. So if we were to identify an extreme value, identify an outlier, and describe how it affects the mean, I would say corn might be a pretty good candidate for it being an extreme value. Okay, so it appears that 66 would be an extreme value. So in order to determine what that effect it may have on the mean, what we're going to do is we're going to calculate the mean with and without the extreme value to see how it affects it. So we will say, let's see, the mean with 66 in it, okay, or the extreme value, is the sum of the values divided by the number of values. Okay, so the sum of the values, I add 14 and 30 and 20 and 25, 17, 28, all of them in there with 66 in there, and I get 262, and there are 1, 2, 3, 4, 5, 7, 8, 12 of them. So that means the mean with my extreme value in it is approximately 21.8 calories per serving of vegetables. Now, I can calculate the mean without 66 in it, or the extreme value. So it's the sum of the values divided by the number of values. Let me clear that up. The number of values. And in this case, what I'm going to do is I'm going to strike this one from the record. So now when I calculate the sum of the values, 14, 30, 25, 20, 17, 28, I'm going to skip over 66, leave it out. Okay, so I took 66 actually out of 262, and I get 196 divided by, well, now I'm only taking 11 points of data, so I divide by 11, and I get about 17.8 calories per serving. So the extreme value increases the mean by about 4, because the mean without the extreme value in it's 17.8, the extreme value with the mean in is 21.8, so that huge value of 66 underneath there pulls the mean from 17.8 to 21.8. Alright, so I guess in practicality you could look at this and say, well, 21.8, okay, if you're a nutritionist, if you're talking about food and you and your parents are talking about being healthy and eating good vegetables and fruits and things, 21.8, you say, well, 21.8, maybe that's a lot of calories, so maybe vegetables aren't all that healthy. Okay, well, when you look at it, corn really pulls on that average, doesn't it? Because without that, the average is less. Okay, 4 calories per serving, not a big monster. But you can see at least the general idea there. When you start talking about, you know, millions of dollars or batting averages or things like that, you can see it can really start to pull if you end up with an outlier. It could really sway the mean, and the data might say something that you might not want it to. Here's an example where we can use measures of central tendency to analyze data. Okay, so compare and contrast central tendency of the two salaries for the two stores, Sports Superstore and Extreme Sports. Based on the averages, which store pays its employees better? So looking at the Sports Superstore and the Extreme Sports store, we can find first the mean. Okay, and the mean is the sum of the two. Alright, so let's do Sports Superstore here and Extreme Sports here. So if I add up the hourly salaries for the Sports Superstore, 724, 76, 888, and 6, and then divide by 2, 4, 6, 8, there's 8 sets of data here, so I end up getting about $9.25. If I add up all of the salaries for the Extreme Sports store, 8 plus 9 plus 10 plus 10 plus 10 plus 10 plus 8 plus 9, and divide by the 8 data points they have, I would get $9.25. So the mean appears to be the same. What about the median? Alright, well, the median is, well, how do we find the median? Well, we're going to list them from smallest to largest. So the Sports Superstore, we've got 6, 6, 7, 7, 8, 8, 8, and 24. And 1, 2, 3, 4, 5, 6, 7, 8 of them. So 1, 2, 3, 4, and 1, 2, 3, 4. So the median lives in here between 7 and 8. I add 7 plus 8 together, divide by 2, or find the exact middle of 7 and 8, and I get about 7.5, or $7.50, since we're talking about money. The median for the Extreme Sports, well, I will list them. I get 8, 8, 9, 9, 10, 10, 10, 10, and 1, 2, 3, 4, and 1, 2, 3, 4. So the median lives in here. So it's exactly halfway between 9 and 10, which is about 9.5, or in money, $9.50. And the mode is the one that appears the most, and the one that appears the most in the Sports Superstore is 8. There are 3 of them, so the mode is $8 an hour, and the mode in the Extreme Sports store is $10 an hour. So which one is the better, or doing a better job, I guess, paying their employees? The mean is the same. The median, it looks like the edge goes to Extreme Sports. The mode looks like the edge goes to Extreme Sports. Okay, so which one would you rather work at, do you think? Would you get paid better? Right, probably you'd think Extreme Sports. Well, why then are these the same? Okay, well, you could probably figure out right here that somebody at the Extreme Sports store, an Uber manager, maybe it's, I don't know, the owner's son, daughter, cousin, somebody like that, is getting paid a bunch of money that the other employees aren't making. So this extreme value is really pulling the mean of this sports store's hourly salary to sort of skew the data and really give a slightly false picture, because according to the mean, it doesn't matter which one you work at, you're probably going to get paid about the same. But if you look at the rest of the data, everybody at Extreme Sports is making more money on average than the sports store, except for the one person. Sometimes we can work backwards. Like in a case where you know the value of the mean, we can work backward to find a missing value in the data set. Here's a good example of this. If Timmy needs an average score of 92 on 5 quizzes to earn an A, the mean of his first 4 scores was 91. What is the lowest score that he can earn on the 5th quiz to get that A? Okay, so the lowest score means if he got perfect, that might get him to an average of 92. But what is the lowest he can get? And this is a question that happens a lot in math. What do I need to get an A? Or how much do I have to get on this test to score? Well, here's how you can figure all that out. So what we can do is we can first find what is the sum, because the total average, let's see, his A down here. Let me write it this way. His A comes from 5 scores added together. So 5 scores added and divided by those 5 scores has to equal this 92. Okay, well, how many scores, or how many, he's got 4 quizzes already, so what score does he have already? He's got 4 out of these 5, and I can calculate exactly how much that is, because his mean of the first 4 was 91, it says right here, and that comes from adding the sum of the first 4, I don't know what that is, we'll call it x, divided by 4. So multiplying both sides by 4 to unravel, because multiplying by 4 is the inverse operation to dividing by 4, 4 over 4 is 1. So I get x equals 364. So he already has 364, we'll call them total points, I guess. Well, 364 is the score of the first 4 plus the 5th score. Okay, see that? So the sum of the first 4 scores plus his 5th score divided by 5, it has to get me a 92, or Timmy a 92 if he wants an A. Alright, so what do we have to do? Well, I have to solve this equation. Alright, let's do this off to the side over here a little bit. So I've got 364 plus, we'll call it y, and divide by 5 equals 92. So since I have this fraction here, so I'm going to multiply both sides by 5, or 5 over 1. Okay, and 5 over 5 equals 1, so this goes away. So what I'm left with on the left hand side is 364 plus y equals 92 times 5 is 460. Now what I'm going to do is I'm going to subtract 364 from both sides. 364 minus 364 is 0, so I'm left with just plus y on the left, so that's y equals 460 minus 364 is 96. So if he scores a 96 on that 5th quiz, he'll get an A. If he scores 97, of course, he will also. 98, 99, and 100, he will too. But he has to score at least a 96. So now let's see if you can put that into practice when you want to figure out what you need on your next test to get an A. Alright guys, that's it. See you next time.